Welcome back. This is CS50 and the start of week 8. So this animation you saw a moment ago is actually not a movie. It's actually a web page. And this web page is implemented entirely in a language called JavaScript. And that language called JavaScript supports now, or increasingly, technology called WebGL, graphics library with which you can actually implement fancy things like this. Just to either tease or scare, if we actually look at the source code for the page that you just saw playing some music and sound, this is an example of a language called JavaScript that we'll dive into next week. Syntactically, it's actually quite similar to C, but you'll see that this person put a good deal of work into this particular animation. So it did take some degree of effort. Anyhow, today is ultimately about pulling back the layers of the internet and the web and transitioning us from C, much to your pleasure perhaps, and transitioning us to PHP and HTML, CSS, JavaScript, and SQL, ingredients with which we will dive into the web programming portion of the course and a lot of the more familiar technologies that we take perhaps on a daily basis for granted. So know that in just a week or two's time, you will be able to put together yourself websites like this, which I found in the Internet Archive's Wayback Machine this morning. If you go back 10 or so years, I lost quite miserably. But I thought I would take a screenshot of this because this is also a wonderful example of how not to make a website. Besides... It's clear what the website was for, perhaps, but these silly little icons where I thought it would be cool to have this guy in a hood saying, come in, enter, click to enter. Click to enter. It's not a cool feature of a website. Right? You've probably seen this on many websites, particularly those implemented fairly animatedly with a technology called Flash. And, well, this was me learning how to program for the web way back then. It didn't get much better. Then fast forward to senior year, and this is apparently what my website looked like, because I had a Muppets calendar that I apparently thought was cool at the time. So I scanned this in and then had my own server running an operating system called Linux, although an older version than what we're using today. And then I put my professional portfolio of web work and such up here on this website. So I think that's the worst of it, though I'm thinking I actually have all the campaign materials, including the posters and the platform. So I'm thinking of running again this year, if that is allowed. So we shall see. So the internet is something we certainly take for granted. I thought we'd take a quick look, though, with a teaser. It's about 50 or so seconds long as to how the internet works. And then we'll start, as promised, to peel back these layers today and moving forward this week. I give you Warriors of the Net.
He came with a message, with a protocol all his own. He came to a world of cruel firewalls, uncaring routers, and dangers far worse than death. He's fast, he's strong, he's TCP/IP, and he's got your address. Warriors of the Net.
So that is how the internet works. And we will dive into more details over the course of today and this week. So a couple in CS61, if you'd like to go that route. All right. So internet. What is it? We have hundreds of people taking this class, all of whom use the internet, some of whom are using the internet right now. So what is it? In layman's terms. A series of tubes. You've been well educated by The Daily Show. So yes, it's a series of tubes. Google that, and you will, well, we'll Google it now, and we'll lose half the attention of the class. That's fine. So it's a series of tubes, metaphorically, but in real terms, the internet is what? It's some kind of infrastructure that connects hundreds, thousands, millions of computers together in the world. So it's some kind of physical infrastructure that in its simplest form is computer and computer with some kind of connection in between them. Maybe it's a wire, maybe it's wireless, maybe it's satellite, but it's this mesh, as we kind of saw from that teaser trailer, of interconnections among computers. So the internet is some physical infrastructure. What then is the World Wide Web? It's kind of easy to conflate the two, but what is the web? Well, how do you access the web? Obviously with a web browser. And let's push a little harder. When you use a web browser, you usually type in an address. And even though these days most of us are lazy enough that we don't bother typing this prefix, anytime you go to a web page, hidden there is http://. Though that's changing if you have an iPhone or if you have a mobile device that's hiding these prefixes. But that conjures up something more technical. An HTTP is a protocol, hypertext transfer protocol, and it's the language that a web server and a web browser speak when communicating on the internet. So what does all this mean? Well, the web is just a service, right? Email is a service. Instant messaging is a service. Skype is a service that use the internet, which again is this physical infrastructure, to actually make that infrastructure useful. Or you can send emails using one protocol. You can access web pages using another. And that's because computers on the internet, clients and servers alike, all speak these things called protocols. So first, some easy jargon. So client is just like a laptop. It's a desktop. It's something that's not a server. A server, by contrast, is something that lives on the internet. It's almost always listening for connections and requests. And much like a waiter in or server in a restaurant, that server responds to requests from clients. All right, so when client requests something from server and server responds to client, how they exchange that information is called a protocol. So for instance, what's a normal human protocol? Well, if I meet someone for the first time, I might say, hello, I am David. And what do you do?
I'm a student.
I'm sorry. You extend your hand.
Oh, yeah.
Yeah, but you are indeed a student as well. So so in the real world, we have these protocols, maybe silly protocols, whereby if I extend my hand and say, hi, how are you? Typically, the other person on the other end will extend his or her hand and complete the protocol exchange. And that's all we're talking about when we use the web. So what does this really mean? Well, if we actually type in something like www.google.com into a browser on a laptop, on a client, well, what actually happens? Well, at the very highest level, my laptop contacts Google. Google responds, and I see a big search box. And then I can repeat this transaction and actually provide input, this time into the text field. But what my computer is really saying is something pretty simple. My computer, my browser, is essentially sending a very short message saying, get me /, where / generally denotes the root of a hard drive, or in this case, the root of a web server, the default page. And then I just have to mention in my message to the server what language I want to speak. So this is literally what is sent to a server from my browser. And I, obviously, the human, don't have to know or don't have to do any of that, because that's what the browser does. It converts the more human-friendly Google.com into a message like this. What does it mean to send a message? Well, we'll see this too with Mr. TCP/IP in the video in a while. But you can think of my computer as sort of preparing a little virtual envelope, inside of which it's putting a virtual slip of paper, written on which is a message like this. And then on this virtual envelope, my computer has to put some addresses, the to address and the from address. And even if you're not quite sure what they are, you can probably guess to what address am I referring when I talk about the to and the from here. All of our computers have one of these things. So it's an IP address. IP is just Internet Protocol address. And Internet Protocol is, again, just a set of standards that humans agreed on a bunch of years ago. And they decided that according to the IP protocol, every computer on the internet is going to have a unique address. And that address is going to be of this form. w.x.y.z, where each of these letters is actually a number from 0 to 255, with some exceptions. But in a nutshell, it's something dot something dot something dot something, and each of those numbers is fairly small. And quick check. If each of these letters is between 0 and 255, how many bits are being used for each of these placeholders? So it's just 8, right? Because 2 to the 8 is 256. So an IP address is 32 bits in total, which means how many possible IP addresses or computers are there on the internet? Right, so roughly 32 billion maximally. You don't need negative numbers, so we can go all the way up to 4 billion, 2 to the 32. And that might sound like a lot, given the number of humans in the world. But frankly, just a few years ago, even the number of IP addresses being used on campus suddenly skyrocketed. What happened over the past few years that has consumed even more of Harvard's IP addresses than traditionally was the case? Yeah, we all have smartphones, right? Every time you walk into this room, if you've configured your phone for either the Harvard University SSID or the CS50 SSID, you walk into a room and bam, your device has requested from Harvard an IP address. So even right now, Harvard itself has a shortage of sorts of IP addresses, which is solvable technologically. But the world, long story short, is transitioning away from these things, version 4 of IP, to what's going to be called IPv6. And IPv6, just to paint the picture, is going to use not 32 bits, but 128, which is huge. We're probably not going to run out of IP addresses in our lifetime if we all adopt this particular standard. So what goes on then? So I'm a browser. I create this sort of virtual envelope. I write on a piece of paper that message, get slash, using this version, put it inside the envelope. On the front of the envelope, I write the to address, which is the IP address of Google. And then in the top left-hand corner of this envelope, I write my address, which is whatever my laptop's IP address is. Well, just to make this more concrete, if you have a Mac, you might have seen this before. You can go up to System Preferences. You can go to Network. And then you can see exactly what your IP address is at this moment. And as an aside, Harvard owns – no, you can't. You can only see me. Thank you. So you can see on a Mac that this is your IP address if you go ahead and open up your System Preferences and click Network. So Harvard has given me an address of this form, 140.247. As an aside, most Harvard IP addresses start with that, so you can identify them as belonging to Harvard, but Harvard owns others. And then there's some other stuff called subnet mask and router and DNS. We'll only touch upon some of these things, but for more, take CS 143, a networking class. So each of our computers has an IP address, but I don't know CNN or Google.com's IP address, right? All I, the human user, know is that the website is called Google.com, or more properly, www.google.com. So how do I figure this out? How does my laptop figure this out? Well, what's the key word here? What's the spoiler? So DNS, and we actually saw this acronym a moment ago. So DNS is something also that you might have seen over time, at least somewhere on your computer, but it stands for Domain Name System. And all this refers to is a standard set of servers across the internet whose whole purpose in life is to convert domain names, like Google.com, into IP addresses, and vice versa. And the advantage here is that I, and even my own personal computer, don't have to know what Google.com's IP address is, because we can just ask one of these servers. What server do we ask? Well, again, when you boot up your computer on campus, Harvard gives you not just an IP address, but it also tells you what DNS servers to use. Or if you're at home, Verizon or Comcast or whoever would tell you the same kind of information. So now I go ahead and I tell my browser asks the operating system, hey, please ask the local DNS server what the IP is for Google.com. Hopefully, my operating system knows the answer because it talks to a DNS server. That DNS server finally responds. And so now I can write it on the to field of this envelope. And it's pretty easy for me and my browser to figure out what my own IP address is, just like I did as a human a moment ago. So I can write that on the from address, and then I can hand it off to whom? Once I've finished addressing this envelope, filling it with this request, I have to get it to Google. But how does it get there? What's maybe the key word here, even if you're not quite sure how the story goes? Sorry? ISP. OK, so ISP, Internet Service Providers, typically involved. But they're involved because they have themselves a certain type of server, a certain type of computer, generally called a router. So a router. So a router is also maybe a term you've at least heard, right? Cisco and other companies make lots of these things. The name kind of spoils what it does. It routes stuff. Well, what does it route? It routes things like these virtual envelopes. And let me start calling it a little something more technical. Instead of virtual envelope, we'll generally call it a packet. So a packet of information is something like we've been describing metaphorically here as an envelope. So once your computer has this packet ready, it needs to hand it off to someone. And in fact, we kind of glimpsed this a moment ago.